The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Welcome to our webinar today. My name's Alec McCutcheon. I'm a director of UNICOM. We're delighted to be hosting today's webinar, which is on the theme of Cloud and Amazon Web Services. We're particularly delighted to welcome our presenter, Bhavesh Goswami. Bhavesh has got a fantastic CV. He's actually worked for Amazon Web Services, or actually for Amazon in Seattle for 3 years as part of the initial development team for Amazon Simple Storage Service, S3, before moving on to Microsoft, where he managed Cosmos, the cloud storage and big data computational engine. Bhavesh is now a CEO and founder of an organization called cont'd Technologies, and I'm delighted also to advise that he'll be coming to the UK at the end of this month to deliver a training course here on Amazon Web Services. So without further ado, I'm delighted to hand over to Bhavesh.
Thank you. Hi everyone, welcome to the webinar. So today we're going to talk about cloud and Amazon Web Services. I'm sure most of you would have heard about cloud, and most of you might know a fair bit about cloud, but we'll start with a basic understanding of what is cloud computing and why it is such a big buzzword in the last few years. And then we'll talk about Amazon Web Services, and my aim is to give you a very brief overview of many of the Amazon Web Services technologies. Now, Amazon Web Services have a lot of technologies, so we'll try to go through as many as we can today. All right, so what is cloud computing? And Wikipedia says that cloud computing is a delivery of computing as a service rather than a product. And if you look at computing today, it is a product. If I want to deploy my application into to 10 or 20 web servers, then I have to first go and buy those web servers. And if I run out of capacity, if my application is doing really well and I'm saturating those 20 web servers, then I'll have to go and buy more. On the contrary, if my application is not doing so well, I'll be wasting resources. To take an example of one other fundamental commodity, electricity. You will see that electricity is more or less a service now. We rarely think about it. It is connected to our homes and offices, and we use it extensively. I mean, we are using it right now as we speak, but nobody really cares about it because it enables other things, and it is always there, and it's pay-per-use. We use as much as we want. We pay the bill at the end of the month. So it's a very essential thing, but it doesn't hinder the way we do things, right? So the aim of cloud computing is to take computing in the same fashion, where computing is enabling things, but it doesn't become an effort in itself to manage computing, right? So let's look at what traditional IT infrastructure looks like in many of the companies. So you can imagine that you are a company that wants to deploy an application, and that application might need 50 to 100 servers, and the first thing you would have to do, even before you design the application, is to first figure out how are you going to get those machines. And if you own the IT infrastructure, that's a huge ordeal. You have to first invest in something I like to call the physical layer, which is you have to figure out where your data center is going to be. And the data center has to be a place which is very secure. It is not on the earthquake zone, not on the big hurricane path. It's fairly stable electricity and cooling available over there, right? So you have to find the right location to build the data center, or to rent a space in the data center that is already built. On top of that, you need to buy things like machines. You need to buy networking equipment to connect all these machines, and it's a huge ordeal. It requires a lot of money up front to buy all these things, right? Which is, for startups, it is very hard to come up with this kind of capital. And even for big companies where the primary focus is in something else, like you could be a pharmaceutical company or a bank, where your area of expertise, your business is not in IT, but you see that a lot of banks still have to invest in these physical layers because there is no other choice. This low-level, this physical layer enables something we call low-level hardware resources. So depending on how many machines and what's the capacity of the hard drives on this machine, you might get, let's say, 100 terabyte of storage, right? So a lot of people, most people think in terms of their IT resources in terms of low-level hardware. They would very happily say that we have a 100 terabyte storage, but they probably don't have a count of how many hard drives or how many machines would they have. They might very happily say that they have a 1 Gbps link in and out of their data center, but they probably don't know what kind of networking equipment or what kind of routers they have that enables that bandwidth, right? So unless you work at the physical layer, most people just think in terms of what is the storage, what is the bandwidth, how much CPU do I have in my data centers. And these low-level hardware resources in turn enable something we call low-level software resources. So things like databases, web servers, application servers. Now, nobody has a database just to have a database, right? It's very, very, I cannot think of any good application that directly use the database as it is, right? Databases are used by applications to store data. Similarly, web servers and application servers enable the application. They are not applications in itself, and that's why they are something called low-level software resources. You write your applications on top of that, and your application layers is where you would want to spend most of your time. This is where you would want your developers and your testers and all your innovation happening at this layer. This is a layer which you would spend most of your time, and the lower layers enable you to do so. On top of this, you have your users, and your users could be using your application from different devices, right? So if you have a hosted application, you could use either a laptop or a desktop or an iPad or even a mobile phone to access your application. And they are also from different geographic locations. So they could be from UK, from US, depending on where your service is deployed and what's the use case for the service. So this entire IT infrastructure to build and maintain this infrastructure takes a lot out of you. Even big companies struggle to do so, but for small companies it is just cost prohibitive. It takes a lot of the resources, and it's just not fun to spend time in that. The biggest thing here is that infrastructure is not your core business. No application is a hit with users, or your users don't really care what your infrastructure is, right? I mean, we all use Facebook, and we use Twitter, we use Google search, but I mean, unless you are in this business, you don't really care how Google manages to give such fast search query results, or how Facebook manages to have so many pictures uploaded and downloaded all the time, right? So infrastructure is not their core business. We love Twitter, Facebook, Google because of the applications, not because of the infrastructure. But if the infrastructure is not good, then these applications are useless, because you cannot use the application. They are too slow. It takes too much time to load. So in turn, infrastructure can only create problems for your business. It doesn't solve any problem, right? It is just like electricity. Like if electricity went out in my apartment right now, I won't be able to do this webinar, and all of you might be disappointed with that. But if the electricity is on, I mean, we don't even think about it, right? So infrastructure, IT infrastructure, similarly, is something which can create problems for you, but does not solve problems. And it's very hard to scale. To go from 100 machines to 1,000 machines to 10,000 machines is really difficult. Right from networking, right from renting out big enough space, right from having software engineers. A recent graduate can deploy software to one machine, but if you want to deploy software to 100 machines, you require some software deployment manager who is smart and can write scripts and stuff. But now, if I tell you that you need to deploy software on 1,000 machines, that's a totally different ballgame. That changes the entire game drastically, and you need a really smart guy who is an expert in this field to be able to help you, right? So infrastructure is not your core business, and it's hard to scale. I kind of visualize this with a pyramid where the effort, I like to call it pyramid of effort, and for companies, the effort they put into the IT infrastructure, they see that they're only able to put a very small amount of actual effort into building applications. The remaining of their effort goes into managing and buying this low-level resources, and it becomes a huge problem for them because application is what differentiates them, but actually they spend more time with things which are not differentiated. Users don't care about this. Okay, so how does cloud help in this scenario? So cloud is trying to replace the way you think about traditional IT infrastructure. At the physical layer, cloud wants you to think rack-space cloud servers, Amazon Elastic Cloud Compute, Google Compute Engine, and so on, instead of buying your own hardware, buying your own data centers. So if I want 1,000 machines today, I can log into my Amazon Web Services account and ask for 1,000 EC2 machines, and boom, within few minutes, I'll have 1,000 machines configured and running and networked and have proper IP address and proper routing protocols up to my disposal. I could deploy applications on them. I could do some cluster computing simulations on them. Whatever I want to do, I can run on that. So I end up spending all my time at the application layer, and I don't have to worry about physical layers. And this is the beauty of some of these services. Right, so basically all these three services, Rackspace Cloud Servers, Amazon Elastic Compute Cloud, and Google Compute Engine provide you with machines. And these machines are provided with no upfront cost. So if I want to start these 1,000 machines on Amazon, I pay £0 upfront. I just pay them per hour. So for every machine, the rate could be 10 cents per hour or 20 cents per hour, depending on the machine type. And at the end of using the 1,000 machines, however machine hours I've used, I just pay them back. Right? At the low-level hardware resources layer, you have services like simple storage service. So I no longer, if I'm writing an application, imagine you are Instagram or any of such applications that require a lot of storage. You don't need to worry about storage. You delegate the responsibility to Amazon Simple Storage Service, which is an unlimited storage space, by the way. So you just keep storing whatever data you need to store. At the end of the month, they give you a bill. The rate in US is about, I think, 8 cents a GB of data stored, so it's very economical. Similarly, Azure Blob Storage and Elastic Load Balancer gives you load balancer in the cloud. Right, so this cloud services wants to take over the low-level hardware resources responsibilities from you. And similarly, at the low-level software resources layer, there are services like Windows SQL Azure, which gives you a database in the cloud. Amazon Relational Database Service, again, a service which gives you database in the cloud. And Google App Engine is application engine in the cloud. So you don't have to manage and configure and pay upfront money for your databases and your application service. You just use these cloud services, and they take care of this layer. And at the application layer too, there are a lot of services that are available, which gives you application as a service. So if I want to use, if I want to have an email for my company, cont'd.in, I no longer need to run my own Exchange server. I can just use Microsoft Exchange Online or Google Apps. Similarly, if I want a CRM application, I don't have to buy a CRM application and buy hardware to run it. I can use Salesforce or any other CRM application in the cloud. Right? So the application layers too, cloud is providing you a lot of different options. And these companies are just like a drop in the bucket. There are so many companies providing you resources at each of this layer. So in essence, cloud tries to replace this pyramid of effort, right? Instead of you having to manage this infrastructure, which is, as we mentioned, unrewarding and non-differentiating, cloud wants to take away the responsibility, right? Cloud wants you to take that, and it wants you to focus just at the application layer. So you get to spend most of your time building applications, building cool features, and not have to worry about the infrastructure. Okay, so from then on, we move to Amazon Web Services. So Amazon Web Services is a very, very innovative product by Amazon, and they are they're the first one to introduce a lot of these cloud services. Like we talked about EC2, and we'll talk a little bit more about that, which is renting machines per the hour. That is a novel concept which was first introduced by Amazon. So what is Amazon Web Services? AWS for sure. It's a large group of web services, also now popularly known as cloud services, offered by Amazon.com. They are key innovators in the public cloud space. As I mentioned, EC2 was the first service that provided machine per the hour. S3 was one of the first public services which allowed you to store infinite amount of data with no upfront cost, right? And they are coming up with key innovative technologies that are called disruptive technologies, where they really disrupt the market. They come up with technologies which enable people like Dropbox to build an entire application stack without having to buy a single penny of hardware. So Dropbox lives completely inside of Amazon Web Services, right? So companies like Dropbox can only work on the application layer while the infrastructure is taken care of by Amazon. Similarly, companies like Instagram, most of you might know that Instagram was sold to Google for $1 billion US, and they live completely inside of Amazon. So again, Instagram were able to do such a thing with, I think the employee size is about 12 people in the company are able to manage such a big infrastructure because cloud takes majority of the responsibilities. Okay, so in the next few slides, we're going to talk about some of the services that Amazon Web Services provide. They have a lot of services, so it will be not possible to cover all of them in this presentation. But my effort here is to give you an idea of the major technologies, major services, the most used services, right? And if you want the full list, please go to Amazon's page, aws.amazon.com, and you might get the full list of services there. Okay, so some fundamentals of Amazon Web Services. They have something called regions. Each region is a distinct geographic location where Amazon has data centers, right? So you can choose between, on your screen you'll be able to see all around the world they have data centers, and for example, if your customers are in UK, you might choose the one center in Dublin. If your customers are in America, they have 3 different regions in US where you can choose from. In turn, each of these regions has multiple data centers called availability zones. So you get geographic redundancy, and inside of each region you have multiple data centers, which gives you further redundancy. So if you plan and deploy your services in a fashion that they are using multiple availability zones and also multiple regions, application becomes really highly available and highly failure tolerant, right? So regions and availability zones. Okay, so let's talk about some of the key services that AWS provides. And the first one, and of course the most dear to me because I was a developer for this service, is Amazon Simple Storage Service. This was the first service introduced by Amazon Web Services, and it provides highly scalable, limitless storage space. So you don't have to provision, you don't have to say, Amazon, I would like to store 5 terabyte of data or 7 terabyte of data. No, you just start bombarding the service with your data, and you have limitless storage. You can just put as much data as you want at the end of the month, depending on how much data you have stored, you get the bill. It provides storage as a service. So not only you can use the UI and upload data, but the power of S3 is that it provides you with REST and SOAP web services APIs, and you can use these APIs to store data directly into S3. So now you can write programs, or your application can in turn call the storage APIs and store data directly into S3. So you can imagine if I want to write a mobile application, and most mobile phones don't have a lot of storage, I can have the mobile application directly store its data into S3. It never has to touch the local storage of the mobile phone, right? And that's how services like Dropbox operate. Is to call the storage APIs provided by S3. S3 provides 11 nines of durability, which means that if you have stored 10,000 objects or files into S3, the loss of a single object is 1 in 10 million years, right? So it's very, very unlikely that S3 will lose an object. The last stats that I've heard out of S3 public stats is that S3 has 1.3 trillion objects. So imagine a system with 1.3 trillion files. That's S3, and they've been in operation since 2006. And as far as I know, publicly nobody has come out and said that S3 lost our data. So they have not lost any data publicly, at least in the last 6 years, in spite of the fact that they have 1.3 trillion objects. It is really fast and highly available. It was designed for 4 nines of uptime, so 99.99% of time, which roughly translates to 52 minutes of downtime a year. This is phenomenal. This includes the hardware failures, the software failures, the deployment time, everything, including everything. It's only down for 52 minutes a year. And as Amazon gives a guarantee that if the availability was ever lower than 99.9%, then they will refund you your money. They will give you back the service charges that they will charge you, right? And they have a pay-as-you-go model, as I mentioned. Is the cost in US East, I believe, is about 9 cents a GB for data stored per month. So they have very, very competitive rates here. The next service in the storage layer is something called Glacier. So this is designed for data archival, right? So most of the data in a company, only 10 to 15% of the data is the one that is used often. The remaining data is just for the archival purpose, just in case we need the data. For such data, you can store it to Glacier, and it only costs 1 cent per GB per month. This is phenomenal. So 1 terabyte of archival storage costs you $10 a month. Phenomenally low price. The only downside is that if you want to ever access the data, it takes a while. It takes a while for you to kind of request the data, and you get a notification from Glacier saying where the data is available, and then you're able to access it. So it is not S3, it's not the data is always available, but it is really cheap, so it is very good for full data archival. And you can have you can set rules so automatically data moves from S3 to Glacier after X number of days. So you can say that I have this log directory in S3, and I only want the last 3 months worth of logs, and after that it's okay for you to archive that to Glacier, and that feature is available. The next is AWS Storage Gateway. This is used when you have a local storage device in your data center and you want to make a copy of your data backup into S3 without changing the software or the device, right? So this storage gateway kind of sits in between the application and the actual storage device, and automatically routes the data to S3 and makes a copy of that, right? So you have backup of it, backup of the data without having to really change your application or your device. The next service is called AWS Import Export. So you can imagine that you want to move to AWS, but you have 1 terabyte of data or 10 terabyte of data or 20 terabytes of data, and it is very hard for you to upload that using the internet connection you have. Your internet connection might not be as fast, so it might take months for you to upload that data. And if that is the case, AWS allows you to do something called AWS Import Export, where you copy your data into a physical drive and you ship the drive to the AWS data center. AWS then takes the drive and loads the data into your account. So you can imagine that you have 20, 25 terabyte of data, which could take a long time. Now you can just copy it to a storage device, ship the storage device, and S3 will copy it. AWS will copy it to your S3 account. So it's very, very fast for bootstrapping project. Also, a lot of people do collect data on the field. So you have some scientific experiments that you're doing in Antarctica, for example, and rather than sending the hard drive back from Antarctica to your thing, you can send directly to Amazon, and Amazon will load that data to your account. Right? So good for either importing or exporting data out of AWS. The next set of services are for compute and networking, and the one that is the most popular AWS service is called Elastic Compute Cloud. This was a game changer when it was released, because now you can start publicly accessible servers in minutes and using web services. So you can actually write a program that in turn calls the APIs and starts this service for you. And you have a lot of machine types to choose from. You can a lot of hardware types to choose from. You can go from 1 to 8 cores. You can get a very tiny machine with only 600 MB of memory, all the way to a mammoth machine where you can get 68 gig of RAM. So we have a lot of hardware type to choose from. We also have a lot of operating systems to choose from. They almost have all the Linux flavors, and they also have Windows Server if you want Windows machines, right? So you choose the hardware and the operating system that you want for these machines. On top of that, there are also a lot of pre-configured machine types. So, for example, you might want to give an application that requires a LAMP stack, Linux, Apache, PHP, MySQL, and you don't need to get a machine and install the LAMP stack. There are a lot of pre-configured machine types that come with the LAMP stack. You can just request a machine with the LAMP stack, and when the machine boots up, you already have the software pre-installed. You just need to deploy an application. Similarly, let's say you want to write a WordPress blog, you can just request for a machine that already has WordPress pre-installed, and you don't need to do anything. You just deploy the machine and start writing your blog, right? So it's makes very easy to do some of these things, and you only pay per hour for the instance and for the external bandwidth. So you can imagine some scientific community wants to do a research, needs 1,000 machines, but only needs them for 2 hours a month. They don't need to buy this machine. They can just request 1,000 machines, do the simulation for 2 hours every month, and then release it. And they get only charged for 2,000 machine hours per month, which is way cheaper than buying and maintaining these machines. The next service is something called VPC, Virtual Private Cloud. So imagine all the functionalities that EC2 provides, machine per the hour, a lot of pre-configured hardware types, pre-configured software type. On top of that, it allows you to create your own private and public subnet. You can imagine that you have a data center where you have some application running and you just need 5 more machines or 10 more machines, but you want these machines in such a fashion that they look like they're part of your own subnet, and you want to be able to assign IP addresses to them, so you can control. You want to be able to control the routing protocols that this machine follows. All this can be done using VPC. VPC gives you full access to control the network of the small little subnet that you created, right? And for the private subnet, you also have the option to only allow access to the VPN tunnel. So if you want to, you can imagine that you want to deploy an application which is only internal application, which can only be used by people of your company, and you only want access from inside your own company network. And you can start a VPC, a private subnet, start the machines, deploy application, and then start a VPN tunnel from your data center to the Amazon data center, and only your infrastructure will have access to those machines. Even though they are started in the cloud, nobody will be able to even discover them, let alone connect to them, right? So it's a very powerful way for you to start machines in the cloud, but still manage the security and the networking aspect of those machines. The next service is something called elastic load balancing. So you can imagine that you took 20, 30, 100 machines, your application is deployed on these machines, but you require a load balancer so that the load can be distributed between this machine. And elastic load balancer does exactly that. You can start it with a web service call or using the UI. It takes a few seconds for it to start up a load balancer, and then you can add your machines to the load balancer, and it nicely round robins your traffic to all these EC2 instances that you just started. It is very economical. It is only 2.8 cents per hour and 0.8 cents per GB of bandwidth, right? So it's really economical service which you can use with your other services deployed on the AWS infrastructure. The next service is called auto-scaling. So you can imagine that you are e-commerce website, you have a lot of traffic during the day, and during night you don't have any traffic, and it is very hard to manually go and release machines. Instead, you can use something called auto-scaling, where you set the rule up. You can say that, okay, um, if the average CPU on my machine is more than 60%, then add capacity, because if the average CPU is 60%, already my machines are working really hard. And if the average CPU of my machine is less than 20%, let's say, then release capacity, because the machines are underused. So you can set these rules, and Amazon will automatically add or remove capacity from your infrastructure um, when these rules are fired, right? So it is very good way to manage capacity so that it scales up when you have high traffic, and it scales down to reduce cost when you have low traffic. You can set rules based on CPU, based on a lot of, like, I think it's about 50 to 100 different parameters you can set the rules on, including CPU, network in and out, the disk I/O that the machines are doing, and you can actually generate your own metrics and then define rules based on those. So for example, a good metric for you is number of users logged into a single machine. So you have to first publish that, and then you can make a rule saying that if an average number of users per machine is more than 10, then I need capacity, then add more machines, right? You can also set rules based on time of day. If your traffic is very predictable, you can do that. So auto scaling lets you scale up or down automatically. Next service is called Route 53. This is a very highly available and scalable domain name system, DNS. And you can access this using a web service. You can change and modify this DNS using web services API. You can imagine that you might actually have 3 different set of websites. Let's say you're an e-commerce site, and you could have you have the same domain, mybrilliantecommerce.com, and you want the UK customers to go to the sites deployed in UK, and you want the customers in US want to go to the sites deployed in US, and you want this to use the same domain name, right? Route 53 allows you to do that. You can say that route my user to the nearest available infrastructure, right? So all the UK and European Union people will be routed to the UK infrastructure, while all the American, North American, and South American infrastructure people will be routed to your infrastructure in America. Right? So it's a very easy way for you to round robin between 2 installations, or to make sure that a single domain name can be used for multiple installations. All right, so the next set of services are for database, and the fastest growing service in the history of AWS is something called DynamoDB. It's a fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. So what this means is that most of the times when we design an application, we start from the application layer. We say, okay, I want an e-commerce solution that can do 20 requests per second, right? And then we slowly translate that to say, okay, how much capacity do I need at the hardware layer? Sorry, at the database layer. So you would say, okay, database, I need 30 reads per second and 20 writes per second, right? And then the DBAs come to the picture, and they start designing the database so they can support this read-write traffic. DynamoDB changes this totally. So you have a knob where you can say, I want 5 reads per second and 10 writes per second at this moment, because I'm in development. And just before you want to go production, you just want to change that to 100 reads per second and 200 writes per second. You just need to change that knob, just need to let DynamoDB know that this is the new capacity you want, and automatically it changes the physical hardware infrastructure it is deployed on automatically without you having to do anything, and it scales up to meet the request rate that you provided. Similarly, after a while you realize that you don't need this much capacity, you can dial down and automatically DynamoDB releases the resources if you dial down, right? So it is a fully managed database service. You don't need to worry about scalability. You just need to tell Dynamo this is just the amount of read and write per second I need, and it will scale up. And I have seen systems do thousands of reads per second on DynamoDB. So it's that powerful that at the database layer you can do thousands of reads per second, and it scales very nicely to support that kind of read throughput. The next database service is called Amazon Relational Database Service, RDS. With DynamoDB, one thing I forgot to mention is that it's a NoSQL database, right? So it's not a pure relational database. It's a new kind of database breed called NoSQL databases, which don't have very strong relational entities tied to each other. With RDS, it gives you relational databases. So it gives you SQL Server, MySQL, and Oracle databases in the cloud, and they are fully managed. So what this means is that I don't need to worry about applying patches, I don't need to worry about backup or security. All this is being taken care of by Amazon. I just get the endpoint and I just access the database using the endpoint, and everything else is being taken care of by Amazon. You can start a database in seconds, you can add read replicas in seconds. A lot of cool features are supported by RDS. The next set of services are for content delivery, and the most popular one is CloudFront. CloudFront is a CDN. So most of you might know that the Content Delivery Networks, or CDN, works to distribute your content throughout the globe. So you can imagine that just, I believe it was like 6 months ago or so, some video on YouTube, the Gangnam Style video, became very popular. So if that was hosted in somewhere in Taiwan, right, and everybody is accessing it all over the world, accessing it through the Taiwan data centers, very rapidly the entire IT infrastructure, the internet infrastructure all around the world is going to be disrupted because of this, right? So CDN actually makes local copies of this all around these edge locations, and the content is delivered from the edge location. So it will quickly copy all these contents in number of edge locations in USA. So if the US customers go get data from there, it will quickly copy it to the edge locations in UK, and UK customers will then get their video from there. So it will actually disperse the actual thing which is being seen and reduce the latency and network traffic, right? So CloudFront is a CDN. Amazon, I'm sure you've all heard about Hadoop. So Elastic MapReduce is a Hadoop cluster on demand. So you can imagine that to have a Hadoop cluster, first you need to buy hardware, then you need to deploy the Hadoop binaries on all the clusters. You have to manage it. Every time there's a new patch, you have to apply the patch on all the machines. And you don't end up using machines 24/7. Most companies have a Hadoop cluster which are not, the CPU is not consistently utilized all the time. So Elastic MapReduce gives you Hadoop on demand. You just click a button, say, I want a 100 node Hadoop cluster, and that's exactly what you get. And you can run your jobs, and after a couple of hours when you're done, you can release the cluster, and you are only charged for the 2 hours that you had cluster up and running. And when you are not running the cluster, when you release the cluster, you are not charged. So it becomes really economical for these small and medium companies to run their big Hadoop jobs, one-off Hadoop jobs on this cluster, and not have to pay for the hardware and software installations. It supports the Elastic MapReduce supports Apache Hadoop distribution and the MapR distribution of Hadoop. So both of these are supported. Also, if people know about this, they also support things like Pig and Hive, which are binaries on top of Hadoop, and those are also supported by Elastic MapReduce. Right, so it's a big service for big data. It allows you to provision machines in minutes and use it. The next service is something called Redshift. So again, the problem with Hadoop for some people is that it's not a relational database, where it is not You cannot write pure SQL queries on top of Hadoop. And if your system is such that you need to write relational queries, then you can use the big data service by Amazon called Redshift. This is just released. It's a very, very new service. But what Amazon promises is that it's a fully managed petabyte scale data warehousing service in the cloud. So even if we have petabytes and petabytes of data, you can use Redshift, and it supports the same SQL-based tools. So it supports SQL queries just like any other SQL-based warehousing tool would support, right? So you don't need to change your SQL tools or your business intelligence applications. You just need, you just want to move to Redshift. You can move, and your infrastructure changes drastically, but the tools and technologies you use will remain the same. I saw some analysis that a 1 petabyte data warehousing only cost about $1,000 on Redshift, versus I think it costs like 10, 20, 30 times that if you were to buy the hardware and software and do it yourself kind of thing for data warehousing. Okay, so the next service is called Amazon CloudFormation. This is an easy way to create and allocate a lot of resources. So you can imagine that you have a load balancer, that you have EC2 machines, that you have a database, all inside of the Amazon Web Services infrastructure. Then it becomes very cumbersome to always start the stack, and when you're done with it, delete the stack, and when you want the stack, again start the stack. So CloudFormation allows you to define your stack in terms of a config file, and then you can say, I want to start this config, click, and it automatically starts the entire stack for you. And it will start from priority order, so it will start to, it will only start with the database first, and the database startup fails, then there is no need to deploy the higher stack. So it will just roll back and send you a message saying, I cannot create the infrastructure because the DB startup failed. So you know, it's much better than you have some script which just starts infrastructure willy-nilly, where you have all the infrastructure but you don't have the database, and the rest of the infrastructure is just useless, right? So it's very nifty to quickly start and stop infrastructure on AWS. The next service is kind of a really, really interesting service called Amazon Mechanical Turk. This is something called cloud sourcing. In the cloud sourcing, so imagine you have a problem where you need to classify 1 billion images, right? And you want to classify these images in terms of whether they have human images in that or not. So if there's a human face in the image, you want to classify it as has human face, and it doesn't have a human face, you want to classify that as it doesn't have a human face, right? So doing this on computers is really, really hard. We don't have really good algorithms that can detect face, especially abstract face, out of an image. Google and Facebook and them, they are working really hard to fix this problem, but it's still really difficult. So if you had to write an algorithm to classify a huge number of images, it will take you a very long time. It will take a lot of your resources to figure out whether you have, you know, a lot of programming resources, a lot of CPU resources. But for a human, it is really, really easy. So if you even show a 5-year-old child image and ask her, is there a human in this image, she would very easily tell you, yeah, that's a human figure here, right? So Amazon Mechanical Turk allows you to crowdsource. What this means is you just upload that 1 billion images on the Mechanical Turk, and Mechanical Turk instead has all these humans working for you. So for 1 cent an image or 2 cents an image, there are actually thousands of these human workers who are able to say, yeah, there's a human in this image, there's not a human in this image. So they will classify the image for you, right? So this huge horde of humans will classify 1 billion images, maybe a day, which would have taken you months to write an algorithm with a fraction of the cost. Similarly, conversion of audio to text, things like that, where humans are much better than computers, can be done using Amazon Mechanical Turk. Right, so really interesting service. So there are way more services by Amazon. This is just the tip of the iceberg. there's possibly I cannot cover all the services in one go, but if you want to read more about it, please go to AWS and Amazon.com and investigate about all the services. Also, we have a course on 27th and 28th of February that I'll be taking in London called Cloud Computing with Amazon Web Services Level 2. It's a very hands-on course where we learn how to use some of the services. So we do a deep dive on S3, EC2, RDS, Elastic Load Balancer, and auto scaling, right? So it's a very hands-on course. We have plenty of labs that we do in the course. So if you need more information about this course, if you want to join, please go to the unicom.co.uk/cloud-computing or email info@unicom.co.uk, or you can write down this number and call Unicom on this number. If you have any questions, please type your questions. I'll take a few questions right now, otherwise, if you have any other questions in future, remember you're welcome to email me at bhavesh@cloudnet.in. You can also follow us on Facebook or Twitter. All right. So with that, Alec, I give the mic back to you, and if there's any questions, I'll be happy to answer them.
Thank you very much, Bhavesh. I think it was an excellent webinar. Please let us know if you've got questions you'd like to type, and Bhavesh will be delighted to take them.
Okay, so I have a question, and the question is, Amazon Elastic Load Balancer uses which scheduling technique for the processor? So currently, Amazon Elastic Load Balancer only uses round robin. Of course, it does all the normal stuff like health checks, so it makes sure that the machine is healthy, only then it routes the traffic to it, but otherwise it uses round robin. There's also a mechanism to do something called sticky sessions, where the session is stuck to one machine. So if you want that a user always end up on the same machine, even if it goes via load balancer, you can enable stickiness on the ELB. So they're the only options that we have so far. Any other questions? Okay, so the next question is about pricing. So the pricing, I know I had pricing on some of those, but not all. It is a fairly there are a lot of criteria, a lot of metrics for pricing. You will have to understand I've seen several TCO to cost of ownership comparisons, and I've not seen a single comparison where somebody can convince me that it will be cheaper for me to have my own hardware. In every comparison that I've seen, having infrastructure on cloud, whether it be AWS or Google, it is always cheaper to kind of outsource your infrastructure to these cloud services. Okay, so next question is there a warning system so you know if you are near a specified limit of usage in terms of cost? Yes, there is. There is actually the billing now has started something called like I forgot the exact name of the system, but it is something very similar where you set a predefined cost saying that, you know, if I am near this cost, send me a message, and they do so. So you can say my monthly bill is approximately $20 or $200. So send me an email if I'm crossing that, and that is a system for you to sign up for that. You might want to check out, send me an email, and I'll be glad to forward you the exact techniques. Or you can check on the billing portal that Amazon has. Okay, so the next question is, how can you do intrusion detection to make sure nobody else is in your private cloud? Good question. So, a lot of techniques. There are very, very sophisticated firewalls around your instance. So forget about the private cloud, right? Even if you are on Elastic Compute Cloud, which is kind of the public cloud, you have a firewall where you can define a law that the only IP addresses who can access this machine are this IP address range, and that IP address range can be your office IP address range or your home or something like that, right? So then it will block access from everybody else but their IP addresses. But to be honest with you, that you will require to do intrusion detection at the application layer. You have to have proper firewall rules. You can use software. There's a lot of companies also do something called penetration testing, where before they launch the application, they hire a third-party security firm, which tries to kind of hack into your system and see if you have any vulnerability. And if so, they let you know. They tell you that you need to block this, this, this. So when we do any consulting and we deploy any application, we surely use the services and make sure that the infrastructure we have created does not have any security flaws in that. I hope this answers your question. Okay. Somebody is asking me, can we download the recorded session, this current session? I think this will be uploaded on the UNICOM website. Alec might be able to. Alec, is that? Can you please give the URL for the
Sure.
website?
What we'll do, we'll be circulating the recording next week. We'll send everybody a link to it, and also we have a YouTube channel where we put most of our webinars and video interviews up there, which is youtube.com/UNICOM seminars. That's youtube.com/UNICOM seminars, and there'll be there's a whole raft of previous webinars and information up there.
Okay. So the next question is that does Amazon provide direct service to companies, or is it provided by resellers? So there is nothing like a pure reseller. So when I think about reseller, my entire idea is that I buy your product from you and then I sell it to the customer, and you give me a cut in between, right? So I buy something from you for £1 and I sell for £2 and I make £1 in between. There's nothing like that for AWS, but Amazon does have consulting partners. So cont'd is a system integrator consulting partner for Amazon, and we help companies to move to cloud, and we charge our services on top of whatever Amazon is charging, right? So Amazon's our cost on top of Amazon cost, but Amazon in turn doesn't like give us a commission or anything like that, right? So Amazon directly sells to the companies, but most companies don't have the expertise required to kind of use that directly, and they do sort some kind of consulting to help them move to the cloud. The next question is there any Amazon simulator available for research purpose? So with this question, I'm assuming you mean like something that simulates the Amazon cloud, and as far as I know, there is nothing similar to Amazon that is available in terms of simulator. But I mean, this is really, really cheap. I mean, why would you want a simulator? You can, and by the way, Amazon gives a lot of these services for free for the first year that you sign up. You get one virtual machine, EC2 instance, free for an entire year. So just sign up and try it out. I mean, and even if you use few resources, it's really, really cheap. It's like 10 US cents per hour for most machine types. So you use a machine for 5 hours, you are charged 50 cents. That I think is like a quarter of a UK pound, right? So it's really, really cheap. Just try it out. The next question is, can you please provide some information around data protection on personal proprietary data? So security in cloud is a very interesting topic, and we have a one-day course on that we just talk about security in the cloud. It's a very involved topic. Things change drastically when you move to the cloud because a lot of people will have access to that machine in a way that people, the machine started, most of the times are publicly addressable, right? So if you're not secured the operating system well, or if you're not secured the application well, there's a chance people might be able to hack and look at your data. So that is the reason why you really need to understand cloud well. You need to understand what is going on and understand the security on the cloud. And as I mentioned before, that if you're deploying something, take help of some of the security companies and consulting companies, and make sure you have proper security features. So the next question is, what encryption is available for business or personal data in the cloud, including securing data in backups? Good question. So one of the features available in S3 is something called server-side encryption. So you just have to give your data to S3 and just turn on a flag called encrypt my data flag, let's say, right? So when you give the data to S3, it will encrypt it first and then store an encrypted copy on its local hard drive. And this happens out of the box, done totally by S3. You don't have to do anything additional to this. And in turn, your data is stored in encrypted format in the hard drive. Similarly, when you get the data, it is decrypted and then provided to you. So that is one way to do that. There are also a horde of third-party encryption services and binaries available, libraries available, which you can download, and it will encrypt the data before it even touches S3. So it will encrypt at your end, and when you get the data back, it will decrypt at your end. So a lot of these binaries are available. You can use either or. So the next question, if we have machines created in different regions, will Amazon charge $750 per machine of $750 hour per account? So basically, if I understand the question correctly, it depends on where you start the machines. If you start 750 machines in the European region, then you'll be charged the European rate. If you charge 750 machines in US, you'll be charged the US rate, but you're only charged for what you use, right? So you're only charged for the UK or US or whatever you're using. Okay, so that kind of, I think we are also running out of time, Alex, and maybe it's a good point to say goodbye.
Thank you very much. I think we're spot on time. So I just would like again to thank you, Bhavesh, for an excellent webinar, and thank everybody for joining today, and hope to see you in the future. Thank you very much indeed. Bye-bye.
Thank you.